All right, in this video, I'm going to go over section 2.6, real applications of normal distributions. So we learned about the standard normal distribution in previous section 6.1, and then we studied how to find the probability uh, the of the under the standard normal distribution, right, using calculator, so normal CDF, and then we learned the inverse norm, which is interest function calculator, to find out z-score corresponding to the area. That's the probability, right? Given in problems, right? So now we see a lot of applied real world problems of the normal distributions, but we just look at the a couple of examples, one or two examples in the text, the lecture slide, and then we move to the my lecture handout. Okay. So let's see. First one, the conversion formula. So for any the normal distributions can be transformed to the standard normal distribution. Remember that difference between the normal distribution and the standard normal distribution. Normal distribution has a mu, which is the population mean, right? Mu is could be any number, okay? And then sigma, which is population deviation, could be any number, okay? So, but as long as the graph of density curve of the normal distribution is bell shaped, okay, and the symmetric about the mu, okay, then that's the just a one of normal distributions. But for any normal distribution can be transformed to the standard normal distribution, which means that the bell shape standard normal distribution, each density curve has a bell shape and the symmetric about the mu, which is exactly the same property as the normal distribution. But the different thing is what mu in the standard normal distribution, mu must be 0 and then sigma must be 1. Okay. So then see the formula right there. Z is equal to x minus mu over sigma. What is x? X is a value of standard value of continuous random variable of the normal distribution, and then mu and sigma are what the mean and standard deviations of normal distribution. Okay, so using that formula, we can figure out the z score. Okay, g score corresponding to the value of continuous random variable normal distribution x. So using this formula, we could transform the normal distribution to standard normal distribution. Okay, so now see the figure illustrate the conversion from a non-standard to I mean, just normal. Non-standard means a normal distribution to a standard normal distribution. The area in any normal distribution bounded by some score x, see, figure A right there, is the same as the area bounded by the corresponding z-score in the normal distribution, standard normal distribution. Okay, see. So now, then, let's see. Mm, now, definitely, yeah, we're gonna focus on solving problem using calculator, using normal CDF. But let's see just one problems. Okay, let's see solve one problem by hand. Okay, so now example one, see height of a man are normally distributed with a mean of, you see that 68.6. It means the mu is equals 68.6 inches. And then standard deviation, which is sigma, is 2.8. Find the percentage. Percentage means the probability. Okay, of men who are taller than a shower head at the 72 inches. So you see that first one, the height of men are normally distributed. So we're dealing with the normal distribution where the mean is 68.6, the sigma is 2.8. Okay. So now then let's find out the G-score, okay, of the 72 inches. So what we deal with what? I mean, what's the question? The question is to find out what? Here, the question is to find the probability that X is what? Taller than, 72 inches. So X is greater than 72 inches, right? Okay. Yeah, we can directly, figure out that probability using normal CDF in calculator. Okay, but let's do it by hand. Okay, so let me solve this one by converting the normal distribution to the standard normal distribution. Okay, this is equal to probability that z score, okay, is greater than Okay, what's the z-score, by the way? We're gonna find out z-score corresponding to 72. Okay, using conversion formula. So z is equal to, what's the z-score corresponding to 72? Which is 72 minus mu is 68.6 divided by standard normal distribution sigma is 2.8, right? Okay. So now the should be this lowercase z, right? So now the z is greater than I mean that is equal to approximately 1.21. Okay. So now finding converting 72 to z-score, which is 1.21. Okay. So finding the probability that x is greater than 72 is nothing but finding probability that z-score is greater than 1.21. So this probability here, x is a continuous random variable of normal distribution with the mean is 6.8.6 and then sigma is 2.8. And then here, that probability is what? The probability of the z-score is greater than a z-score, which is the what? The continuous random variable of standard normal distribution with the mu is 0, which means the mu is 0 and the sigma 1. Okay. So how can I find this? We use a normal CDF or using table. We can find out the answer. Let's see. In the here, step one, yeah. So solution, what you're gonna do? We just may have heights that are normal distributed with a mean of 8.6, and then sigma is 2.8 in the shaded region. So we just figure out the area. Okay, just kind of illustrate the probability. What problem asking? Uh, the using the graph. Okay, so which this is the graph of the normal distribution. Graph a density curve of normal distribution with the mean is mu is 68.6, sigma is 2.8, and 72 is right there. So area is over here. Shaded region must be the probability what we have to find out. Okay, now and then step two. See, using normal, I told you using normal CDEV, we could directly figure out the probability. Okay, so okay, but here we can convert the that 72, that x value contains a random variable of normal distribution to the z-score using conversion formula. Okay, and then what using a table A-2, because table A-2 show the list the probability of standard normal distribution. Just give me a second. Yeah, as you can see that here, this is table A-2. Again, negative z-score. So this is, you see the figure right there? This is the density curve of standard normal distribution. So horizontal axis represents z-score. Okay, and then the this table represents the shade area of the shaded region, shaded area. Okay, so you see a negative 3.4 means that the first column represent the what up to the first decimal places of z-score, and then you see the first row represent the second decimal the place number. Okay, in z-score. So for example, if you want to figure out the shaded area of the shaded region at from negative infinity to the negative 3.15, then we find the negative 3.1 right there, and then you see that 0.05. So that's the what 0.0008. That's the area from negative infinity to negative 3.15. Okay, and then the other one. Second, a second right here. Okay, so what about the positive z-score? So that's going to be the key mind is the normal distribution, either normal distribution or standard normal distribution area from negative infinity to the mean going to be 0.5, and then mean mu through the infinity going to be 0.5. Okay, so half of the area of the graph must be 0.5. Okay, because the graph is symmetric for both normal distributions and normal distribution. Okay, so so we want to figure out the area from negative infinity to the 1.23. Then we find 1.2 right there, and then 3 is here. See that? 0.03. So 1.23 is a 0.8907. Okay, this is how to read the table. Okay. So in the lecture slide, they are doing two-way, okay, using just a calculator and then using the table, okay. It looks like complicated, right? Step one, step two. I keep in mind this: you don't have to follow the solutions in the lecture slide, okay. As long as you know how to find out the probability using calculator, that should be fine, okay. So just I'm going to use this, but keep in mind this: you need to know how to convert the random variable of normal distribution to the z-score, okay, using conversion formula. So you need to keep in mind this the conversion formula, okay. So now I'll figure out probability, okay, I mean the answer of the problem using the calculator. So in a calculator, we go to the distribution, okay. So now then see a normal CDF, that's what we are going to use. So lower, so what, lower must be 72, right? And this is 72. The problem says, because the problem says that and this is 72. So upper is what, infinity. What, we put the 999, okay? So why we have put 9999? Okay, you don't get it, just please watch the previous lecture video, okay? The mu is what? This is a normal distribution, not standard normal distribution. So mu must be 68.2, 6, right? 68.6. And then sigma is 2.8. Okay, so we paste. Then we're gonna get the 0.1123. Okay, this is how to find out probability. Okay, I mean area between two z-score, two x values normal distribution. Okay, but since we so we figured out z-score, right? Okay, so now then we can find out the probability that z is greater than 1.21, because 1.21 is the z-score corresponding to the the value of random variable 72, right? So we go to the normal CDF again. Okay, lower must be 1.21. Keep in mind this: the answer must be equal. Okay, upper is 999, mu is 0, the sigma is 1. So we're gonna get same answer, right? Approximately same answer, right? So 1.1123, 0.1131, right? But approximately the same, right? Equal. So now the so here, then you may wonder that, okay, so then do we have to when you solve this when you deal with this kind of problem, do we have to find out, I mean, convert the x to z score? You don't have to do that, okay? So, but this problem just asks you to find out z score. Yeah, you need to use a conversion formula, okay? But you don't have to do this, okay? You just find out, I mean, directly find that probably using normal CDF, interest function calculator. So that was a 0.1123. Okay, that's the more accurate answer than you know the number we got using the z-score. Okay, so and then we other examples in the lecture slide is similar. Okay, so we move to the lecture handout. All right, see example. So this is the lecture handout, chapter 4 through 6, and then there's no page number. Okay, so give me a second. Yeah, I see in the chapter 6, number probability distribution. This is the first page on chapter 6. Okay, and then I just yeah, I went through all the stuff using the lecture PowerPoint, okay, PPT slide. Okay, second page, and this is third page. Yeah, in the third page, you see example, other IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. Find the probability that a random selected adult has an IQ between 75 and 135. So how can I find out probability? We're just gonna use normal CDF. Okay, I'll show you. All right, so in the calculator, so we go to the normal CDF. Okay, so the lower must be 75, right? And the upper must be 135. Okay, and then mu is 100. The standard deviation is 15. Okay, and then we calculate. We got the 0.9423, so approximately 94.2%. So 94.2% of others has the IQ between 75 and 135. The next question is this. Find the probability that randomly selected adult has IQ less than 113. Okay. Then we go to CDF and then less than 113. So lower must be what? Negative 9999. Okay. The upper must be what? 113. Okay. So we go for this. Then you're gonna get 0.8069. So approximately 80.7%. Okay. And then now the last problem. Give me a second. Let's see problem C. Is this the interesting? Find any 98 percentile, the lowest score meeting the requirement for a membership in men's high IQ society. So what does that mean? 98th percentile. So it means that this is the you know what's the definition of percentile? This 98th percentile means that what the data value, okay, who's the what the percentage, or can say the position of the data value is 98%. It means that from the what the what 98% of the data value in a sample or population, their values are less than that 98th percentile. Okay, so from the lowest to the up to the up to the value less right below that value, that the are what 98%. Okay, so that out of the whole the data value, 98% of data values, their values are below that percentile. That's the meaning of 98 percentile. So 98%, that's a percentage of what? Probability. So we got to find out the data value, or in this case, random variable, right? We got to find a random variable or a random variable whose probability from the negative infinity to that random variable is 98%, which is 0.98. So we got to use inverse norm, right? So key in mind is whenever you see the percentile, you got to use inverse norm. So find the 98th percentile means that find the z-score, or in this case, not z-score, right? Because this is problem is about normal distribution, not standard normal distribution. So we find out the value uh, the random variable of normal distribution, okay? Okay, whose the area from net infinity to that random variable is 0.98. Okay, keep in mind this. All right, you see in the calculator, we use inverse norm, price second, price v variables. So we see the inverse norm number 3. Okay, area is 98.98. Okay, mu is what 60. In this one, in this problem, mean is 100, right? Sigma is 15. Paste. So we're gonna get 130.8. That's the what x value, which is that's the 98th percentile. Okay. So now the give me a second. Let's see next problem. SAT scores are normally distributed with a mean 1000 and sigma is 100. Find the probability that randomly selected person scores more than 1200. Then we find out what probability that x is greater than, right, 1200, right? Okay. Then using the normal CDF, that is equal to normal CDF, and then lower limit must be 1200, and the upper limit must be 99999. Okay, and then mu is 1000, and then sigma is this. Okay, so now next one, B, find the probability that random selected person scores between 75 and 1250. So probability that x is the between 75 750 and then 1 to 50, that is equal to normal CDF. Okay, 750 and then 1250 and then 1000 and then 100. And now see, find the probability that the random selected person scores less than 700. Okay, so now we figure out that. So P x is less than 700. Okay, that is equal to CDF. Okay, negative 99999. Okay, to 700, 1000, and then 100. Let's figure out this, and then because we need to figure out the answer for the second question, 700 be a significant low score. So let's figure out that. In calculator, we go to the distribution, right? So press second, press variables. So we use normal CDF. And then lower is a negative 9999, and then upper is 700, mu is 1000, and then sigma is 100. Okay. So now then we calculate, we got the 0.001, right? Okay. So then what's the question for the second question? 700 be a significant low score? Yes. Why? Because normally probability that what that probability is less than 5%, which is means that if probability is less than 0.05, we consider that is the significant low. That value is significant low. Okay, so the answer is yes. And then next one, let's see. Problem. Find the top 10%. That is 10% of the people score above what? Okay, so the problem D is to find out. We need to find out what the x value whose area, that's nothing but probability, okay, whose area from that x value to infinity is 10%. So we got to use the inverse norm. Okay, so we use inverse norm. The area is 10%. But keep in mind this, in the inverse norm, okay, this is really important. The key in mind is in the calculator, in the inverse norm, always consider the area as the area from negative infinity to that z-score, that the x value. Okay, what we want to find out. So top percent, to find out top percent, we need to put area. We need to put a 90% in the area, which is 0.9. What that means, because in a inverse norm, let's say this is the normal distribution. Okay, density curve of normal distribution. Okay, density curve normal distribution. Okay, this is random variable x. Okay, so we want to figure out the here's a 10%. I mean, we need to figure out that z-score on x value. I'm sorry, x value. Okay, whose the area from here to infinity is 10%, which is the 0.1, right? But using the inverse norm in the calculator, that area represent the area from negative infinity to what? Negative infinity to here. Okay, so what are you gonna do? So we put what's the area from that shaded region by color blue? 1 minus 0.1, which is what? 0.9, right? So we have to enter 0.9 into the inverse norm. So yeah, the command gonna be what? 0.9 Okay, and then mu is in this example is 1000, and then standard deviation is 100. Okay, we have to enter this one in the calculator, then we can figure out that x value, which is a value of random variable. Okay, whose it's kind of borderline separating from the what, the IQ score less than top 10%, but above the top 10%. Okay, let's see. So in the calculator, there's a 0.9. Mu must be what, 1000, and then sigma is 100. So we passed it. So we got the what? The 1128 score. Okay, not IQ score. I'm sorry. This is SAT score, right? Okay. So the answer is what? 1128 point maybe 2. Okay. Right. So that's the answer. So that's the for today. I mean 6.2. Next time I'm gonna cover the 6.3.